Hi all. Alex, are you hearing me?
Yes, I can hear you.
I've been having trouble all week on getting people to hear me on Zoom. So, well, we'll do our best. All right. First thing I want to talk about, where are you getting your data for the lab? Talk to me. I need to hear from you guys. Where are you getting the data?
I'm getting it from the tab on my courses. It says like student data for labs.
God bless you. Who are you?
Alex.
Thank you, Alex. God bless you. That's where you're supposed to get it, okay? Does everybody understand that? You are not to use the data that's in the videos. First of all, it's incomplete. And second of all, it is wrong data. So please, when you are doing this, please find the tab that says student data for labs and use that one. We good with that, guys? Okay. Veronica's in here. Aisa? Veronica, I just said was here. Kara's here. Cassandra, I think I saw. Cassandra?
Here.
Thank you. Madison just popped in. Ramiro. Yep, I see you.
Yeah, right here.
Thank you. Alex is here. 10. Yeah, it's amazing. I go to call a name and look up and there it's at. Mac is here. Bell. Bell, you here? Thank you, Bell.
Here, sir.
Victoria. I see you,
I'm here.
Victoria. Brittany. Grazie.
I'm here.
And Brian, I saw. Okay, I'm still looking for Aisa and I'm looking for Brittany. Anybody I didn't call?
Me, Madison.
All right, gotcha, Madison. Okay, we're all clear on that. Even if we're not, let's go to the course. Okay. Let me see who's. Well, that's me, so it's not important. Okay. Course content. Look all the way down. About 3 up from the bottom. Well, maybe a little bit further up. Sorry about that. Student data for labs. Click on that. And you got to go all the way up again. Click on it. And amazingly enough, sorry, I have to move you guys to the other side of the screen. Amazingly enough, we have all the data. When you're going to do the hydrate, that's it. That's all you're going to need for the hydrate. Okay? Questions about the data, guys?
So you don't want us to copy everything from the lab manual? You just want us to do this part? This is Mac.
Mac. You have to, I don't understand what you mean. I don't want you to copy everything from the.
No. Because when I did the lab, I wrote like the boxes and steps from the lab manual that you have, but I used these data to put in to use.
Yeah, I do want you to use the boxes, yes.
Okay.
When you're going into the results section, yes, you have to put this information here. For example, it asks you for the density to calculate the density using trial 2. Okay, so you have to show you subtracted 77.8501 and 67.6745 to get the grams of the water. You take that number of grams and you divide it by the 10.05. That would have been everything sufficient to put in the box. Any other questions? Anything else? Okay, I'm going to stop short. Ladies and gentlemen, this should be an extremely easy lab to do. Okay, extremely easy. The calculations, why isn't that popping up? Up there it is. The calculations are very, very easy for this lab. Okay. So are we seeing the PowerPoint labeled hydrates?
Yes.
Thank you, finest kind. Okay, so you have to understand what hydrates are. Okay. There are salt compounds. A salt is nothing more than a metal mixed with an anion of some type. Metal loses its electrons. Those electrons are garnered by the anion. We have an ionic compound. Every ionic compound is a salt. And you're going to hear chemists call them salts. We don't necessarily mean sodium chloride. Now, when salts get made, what happens is they incorporate water within their crystalline structure. It's not really bonded to the salt. It's just incorporated within the crystalline structure. Now, if you heat those crystals, what happens is crystals generally boil they're ionic compounds. They boil at a very, very high temperature. So you're heating these crystals and the water itself evaporates away from the salt. When the water is in the crystalline form, it is called a hydrate. When you have driven all the water off, it's called an anhydrous salt. Now, have you ever seen those little packets they put in shoes? Shake your head, Kara. You have how many shoes in your closet, Kara? She's eating, so she can't talk.
No, I actually only own like 5 pairs of shoes.
Only 5
so
pairs.
I only remember
But
because
still.
it's a huge event for me.
But still, you see the little packets, right?
Little silica packets, yeah.
Exactly. The silica packets are actually silicates, which are salts. And what they've done is they've taken those silicates, heated them up so all the water is out of them. Now, you're in Florida. You're humid. If you put one of those anhydrous things, it's going to suck water out of everywhere. And the main thing is it sucks water out of everywhere so that the water doesn't go on the leather of the shoes. So that's what the whole purpose commercially of hydrates is. Now, if we're doing a mass percent, by definition, a mass percent is part over the whole. That's all it is. You're measuring the mass of the part and you're dividing it by the mass of the whole. Okay? If you set the whole portion at 100, you're just determining how much of that 100 is the part you're interested in. That is the part per 100, part per century, part per cent. If you set the whole portion at 1 million, then you would be determining how much of that million is the portion. That is parts per million. You can actually go parts per billion. These things are really useful when you're looking at things like in the environment, things like determining the calcium quantity in the water. So that is all we're doing. We're taking the part, dividing it by the whole. Part divided by whole by 100, that gives us mass percent. Now, in this experiment, we're going to have two ways of doing mass percent. If you have the mass of the part and the mass of the whole, you just divide the two. If you have the molecular formula, what you got to do is you got to take the atomic masses of the part, add them all up. Then add up the atomic masses of the entire molecule. Add those all up. And you take the atomic masses of the part, divide it by the atomic masses of the whole molecule, you have the mass percent as well. Either way will get you the same number. So the strategy we're doing here is we are going to take a sample. We're going to weigh it so we know how much it weighs before we heat it. Then we're going to take that sample, heat it up. When we heat it up, that's going to drive all the water away. So we're left with just the salt without water. To get the weight of the water, we're going to take the weight of that anhydrous salt, subtract it from the hydrate. That gives us the weight of our water. Then we're going to divide the weight of our water by the weight of the whole thing, the weight of the sample before heating. That will give us a mass percent. Okay? Now we have to figure out what our unknown is. So what you're going to do, you're going to be given a series of, I think, 5 to 7 compounds. And you're going to have to take the atomic masses of the water. And you are going to have to add that up and divide it by the atomic the molecular weight of the entire molecule. Then you're going to compare mass percents. The one that's the closest is your match. That's the formula you're going after. Does that make sense to you? That's the overview of what we're doing. Anybody confused about where we're going with this?
So the numbers that we got that you just show us are how do we use them? I'm confused on that part.
Veronica, I'm going to go through it step by step for you, okay?
Oh, okay.
So I will go through it step by step with real numbers,
Okay. Okay. All right. Thank you.
But bottom line, all we're doing, we're weighing the sample before we heat it. We're putting it into a crucible and we're heating the snot out of it. Okay? Then after we heat the snot out of it, we're going to weigh it again. So the first weight will give us the weight of our hydrate, the weight of the salt with the water. The second one, after heating, that will give us the weight of the anhydrous, the salt without the water. So simply to get the weight of the water, I subtract the two. That's where we're going. That's the entire experiment. So I weigh out a crucible. A crucible is nothing more than a porcelain dish that's designed to heat objects to very, very high temperatures. I weigh a crucible out at 37.832. I add some hydrate to it. That's the salt with the water in it. The new weight is 39.154. So I subtract those two, and the weight I get is 1.322. That is the weight of the hydrate, the weight of the salt plus water. Now I'm going to heat the crucible and the hydrate. But I'm not going to heat it just once. Because if I heat it just once, how do I know I've driven off all the water? What I'm going to do is I'm going to heat it, let it cool, weigh it, heat it again, let it cool and weigh it. That's what I did here. Now, if the weights are less than 1/10 of a gram apart. That means I've pretty much driven off all the water. Are the first two weights less than 1/10 apart?
Yeah, no,
Yeah, no,
yeah.
I can't accept that answer.
Yes.
Yes. Okay, you subtract the second heating from the first and you get 0.177. Is that more than 1/10 of a gram? So there's still water in there. So I'm going to heat it a third time. When I heat it a third time, the third mass ends up being 38.785. That's actually 0.25. That is less than 1/10 of a gram. I now know I've driven off all the water. Okay? So I need to get the weight of my water at this point. So the crucible is weighed, went backwards. So I can get the weight of the anhydrous by subtracting the weight of the crucible and the weight of the crucible and the salt after heating. That gives me a weight of my anhydrous of 0.953 grams. At this point, I have one of two ways to get the weight of the water. I can take simply the weight of the hydrate and the weight of the anhydrous. In other words, the weight before heating of the salt and the weight after heating of the salt. Subtract those two, that will give me the mass of the water. If I don't want to do that, I could take the mass of the crucible and the hydrate. From that, subtract the weight of the crucible and the salt after heating. If I subtract those two, I will come up with the same number. So I have the weight of my part. Now, riddle me this. What is the weight of the whole? The water is my part. What is the weight of the whole thing? We got lots of numbers up here, guys. Somebody guess, or we're going to be here all night. Brittany,
Yes, I have
what do you think the weight of the whole is?
1.6 8 no 9.1. I'm trying to do that without any paper.
What did you do?
I added the mass of the hydrate, mass of the water.
Okay. If you do that, yeah, you can do that. That will work. But the answer you get is 1.322.
Oh.
Okay. Trust me on that. You can get the weight of the whole by taking the weight of the anhydrous and the weight of the water. You can add those two together, but you already had that to begin with, Brittany.
Mm-hmm.
You had the weight of the hydrate to begin with. So to get the percent water, what two things am I going to divide, Veronica?
The mass of water and the mass of the hydrate.
Exactly. I'm going to take the 0.369, the mass of the water, divide it by the mass of the hydrate, and I'm going to multiply that by 100%, and that's going to give me a number, 27.85%. We're halfway done, guys. We are halfway done. Now we have to do the mass percent using the atomic weight masses. All right. If you want to determine whether your compound could be barium sulfate dot 5 waters, what this means is that for every mole of barium sulfate, you have 5 waters that are surrounding it. That's what that formula means. So we have to determine the contribution from the water using the atomic masses. Then we have to determine the entire molecular mass using the atomic masses and divide those two. Okay, I have 5 water molecules. If I have 5 water molecules, this means I have 10 hydrogen atoms. I'm taking those 10 atoms, multiplying it by the atomic mass, and I get 10.08 grams. I have 5 oxygen atoms. Multiplying that by 16, that gives me 80 grams. God bless you. I add those two weights together, and this gives me my water contribution. Okay? Now I have to add the rest of the molecule to it. The rest of the molecule is the barium sulfate. I've got 1 barium times 137.33. I got 1 sulfur times 32.06. That's 32.06. And I have 4 oxygens at 16. I add all of those together. This gives me 233.39 grams. I add in the mass of the water. So the mass of my entire molecule is 323.47 grams.
I have a quick question for you.
Okay?
The numbers that you're getting, like the 137.33, that is the atomic mass, correct?
Correct.
Okay.
Correct. And the only thing I need to worry about is I need to worry that my masses aren't going to exceed. My masses aren't going to exceed 5 sig figs. Masses, my data masses are not going to exceed 5 sig figs. Okay? So I now have the weight of my whole, which is 323.47. I'm going to divide that into the weight of my part, the weight of my water. It's 90.08 divided by 323.47 times 100. This ends up being 27.85%. Now, the 27.85%, I'm going to compare to the percent water I got from doing the masses from the experiment. They match up pretty good, so I know that my formula is barium sulfate dot 5 H2O.
So
Questions?
so the last mass that we got is not the mass percent of water, the mass water.
They're both the mass percents. Okay?
So
It's
what
not
was
going to
the-
change. Veronica, if you figure out mass percent by
Mhm.
either weighing the atoms or by doing the atomic weights, either way will give you the same mass percent. Okay, let me see if I could do a quick example.
Are these notes and lecture notes available somewhere?
They're in the Zoom, they're in the PowerPoints. PowerPoints are the last folder in the course at this point.
Okay, thank you.
No. Okay. Okay, I'm going to give you a, okay, Veronica,
Okay.
I'm going to end show. And I'm going to show you how this is. Stop it. And show. I'm going to show you how you get the same percentage, whether you use the atomic weights or whether you use grams. Okay.
Okay.
Damn it. That's what I want. Okay. So if I have sodium chloride, okay,
Mm-hmm.
my sodium weighs 23 grams per mole. My NaCl weighs 58.5 grams per mole. Correct?
Yes.
All right. Divide the part by the whole. If I want to know how much sodium's in there, I divide the sodium by the weight of the entire molecule, and I get 39.3%. Okay?
Okay.
Okay. Now, I did an experiment. And I found that my powder weighs 88 grams. I assayed it and found that there were 35 grams of sodium. Okay.
Mm-hmm.
So if I'm doing this by weights, I divide the part by the whole and take it times 100. And I get 39.7%. Now, isn't 39.7% real close to 39.7 is real close to 39.3?
Yes.
Is it, Veronica? It's
Yeah.
within experimental error. Okay?
Okay.
Literally speaking, because there is this ratio is going to always exist no matter how much powder you have. Okay? Give me a number, Veronica.
5.
What?
5.
Okay? So if my powder weighs 5 grams, then 39.3% of that 5 is going to be equal to the weight of the sodium. Does that make sense to you, Veronica?
Yeah, a little.
Okay, so I'm going to take the 0.393, multiply that by 5. So I get basically 1.97 grams of sodium. Right, Veronica?
Yes.
So if I want to find the mass percent, I take the part, divide that by 5 times 100, and this would be equal to
39.
39.3%. No matter what number you come up with, Veronica, for the weight of the salt, no matter what number you come up with for the weight of the salt, 39.3% of that mass will always be sodium.
Okay.
You buying it now?
Yes.
Okay. Guys, pretty much that's pretty much everything I have from this particular lab. Anybody have any questions?
I do if you're still willing to stay after to talk.
Brittany, yes, I am planning on talking with you. Okay.
Just
Do
to
you-
make sure.
Do you want me to go through the results section?
Please.
Okay. I got to do it the other way. It's not going to give me the quiz. It's not going to give me, I hate computers.
I agree.
Unless, of course, I'm trying to get a cheap flight, then they're rather handy.
It's only when you're goofing off do they want to work. It's when you need it to work the most. It doesn't ever want to function.
Thank you
It's how
so
it
much.
works.
You made my night.
Oh, I work on a computer all day for work, so believe me.
Okay, so I'm going down. Okay. Preview. Guys, you're going to be incredibly impressed at how easy this is. Unknown number. 45 is your unknown number. If somebody puts a number other than 45, you lose the 5 points. Okay? Calculate the mass of the hydrate. Guys, all you have to do is follow through that sample calculation I give you. Okay? You're going to need to do mass of crucible and hydrate minus the mass of the crucible. That will give you that number. Calculate the mass of the anhydrous salt. Same thing. Mass of crucible and salt after heating minus mass of crucible. That will give you the mass of the anhydrous. Mass of the water. You can do it two ways. Mass of hydrate minus mass of anhydrous, or mass of hydrate plus crucible minus mass of anhydrous after heating plus crucible. You got 25 more points there, guys. Calculate the percentage of water. You have the weight of the water. You have the weight of the whole. Divide that by each other. You have the weight. I don't believe he gave you two trials. I think he just gave you one. So don't worry about the average. Now, you got 5 samples. Okay, if you remember, the second half of that of the PowerPoint dealt with finding mass percentage by atomic weights. You got to get the whole, the weight of the entire mass of salt. Remember, when you have a number in front of water, that's multiplying H2O by that number. So find the weight, atomic weight of the water in there, divide it by the whole weight. That will give you a percentage. Then, whatever percentage you got here, compare it to the percentage you got there. and identify your unknown. That's it. Ooh, thank you, Mr. Popovich, for giving us an easy lab. Oh, thank you, thank you, thank you. If you're looking for these things, if you find one of these that has a 51.12, say for example, it's calcium chloride .2H2O, you would put the 2 in there. Anything else I could thoroughly confuse you about?
I'm a little confused. So. The identify unknown would be what?
Okay, Veronica, you are going to use the atomic masses to figure out the percent of water within this compound. It's going to be one of these 5 numbers. Okay, each one of these will correspond to a percentage. All right, you have already determined the mass percentage because you did the experiment and you got the weights. You got the weight of water and you got the weight of the hydrate. When you divided those, you got a mass percent. You're going to compare the number you got in question 3 with these 5 numbers.
So I will put more than
One of them-
percentage on
No,
number 3.
there's only one that's going to match.
Okay.
The one that matches that formula you put down here.
Oh, okay. Okay.
Anything else, guys?
I do have a quick question. This is Tori.
I'm sorry, this is who?
Tori, Victoria.
Okay. You'd like to
The,
be called Tori?
yeah, yes.
Okay, I
Um,
will make a note of that. I asked what you people like to be called. Go ahead, Tori.
after the results page in the lab manual where it has us calculate the mass percent of water for the known hydrated salts, is that going to go in our lab report under the results?
It should, yes.
Okay.
It should go in there on the calculations.
Okay.
You're gonna have to show in the lab notebook all the calculations that you're doing here. Okay? And I do not want that. I do not want the calculations within the data table. I want a separate section for the calculations. Okay, Tori?
Thank you.
No problem.
One last question for the post lab. Is there anything special that we need to be aware of, or is it just a straightforward little quiz?
That would entail I actually looked at it. Do you want to see it?
Sure, why not?
It's a super secret one. If I show it to you, I gotta kill you.
I might take that risk.
Okay. What am I doing? I'm in the wrong thing. Why do computers do what you tell them to do rather than what you want them to do? Okay. Start quiz. Okay. A student follows the experimental procedure. This is the same formula I gave you earlier when we were talking about notebooks, when I went through the notebooks. Experimental percentage, that's the result you got when you actually did the experiment. The known value would be the value of using a known sample, a known standard. In this case, the known standard, the known percentage is the one that is involving the calculation by atomic masses. That is the known value. The experimental one is the one you got when you heated the sample. Okay, so it's telling you that in this sample, the student did the experiment and they came up with an 28.36% error, or 28.36% mass percent. The true value is 29.78. So simply plug this value in the experimental, this value in the known, divide by this value, multiply it by 100. That will give you a percent error. That number tells you how close you were to getting the right result. Okay? Let's look at this. A hydrate was known to be 25.67%. That's what it is known to be. Your results showed that there was 18% water, 32% water, or 52.73. Okay? What can you say? Do you know what the difference between accuracy and precision is?
Yeah, accurate. It's like it is like yeah.
What's accurate? Tell me what accurate is.
What I have, like what I think it is like if they give you a table and you did an equation or something like that, and it gives you it's the exact number that is accurate. Does it make sense? What I'm trying to say?
Kind of, sort of. If you, accuracy means, did you get the right answer?
Yeah.
That's simply what accuracy means. Precision means, were you able to replicate your answers? Can you answer the precision part here? Can you? How many times did you do the experiment?
There was 3.
Okay. Did you get the same answer?
No.
Let me ask that question. Should you get the same answer each and every time?
At least similar, maybe not the same.
Okay.
I mean, if you're using the same numbers, yeah, you should be getting the same thing. But if you're doing the experiment 3 different times and you're using 3 different numbers, then they should be similar.
Okay. Are they similar?
No.
So, is it precise?
No.
No.
Okay. Now, these are your 3 answers. How would you determine whether you got an accurate result?
Wait.
What's your answer? Guys, what is your answer? What is the percentage? You did the experiment. You came up with 18.72, 52.73, and 32.74. What is the percentage?
25.67,
How'd you get that?
because it's right there in the question. It
Okay.
says it's the known percentage.
Well, how close did you get to that?
Not very.
How do you know that? What do you have to
Because-
do? What do you have to do to make that comparison?
Are you talking about minusing from each other and then timesing it by 100? No.
Nope.
Okay.
Got to do something before that.
Calculate the percent error.
But what do you have to do before you get the percent error? What's your result?
You mean the fact that your results have to be accurate?
No. You're trying to determine whether you're accurate. What is your result? If you had to put your money down so that you were spending, you were betting next month's mortgage payment, what would you say the percentage from the experiment is? You don't know the 25.67 yet. All you have are the results from your experiment. What are you going to call your percentage?
Precise?
No, we're not talking precision. All I'm asking right now, what is the percentage that you would report out? And how would you come to that number? Okay. Let me see if I can come up with a number. Okay. Kevin Kiermaier, baseball player. Sorry, I got to use a baseball thing because I'm into statistics. All right. Kevin Kiermaier, first year, came up, he had 100 hits. Second year, he had 150 hits. Third year, he had 200 hits. If you were a betting person, how many hits would you think he would have in the fourth year?
250.
What? How'd you come up with that number?
He's been going up by 50 every year.
Okay. Kevin Kiermaier had 100 hits his first year, 200 the second, 150 the third.
Well, then I wouldn't bet on him because he's going down.
But he went up.
But then he went down.
What can you use? What can you use to figure out how many hits he's going to have?
Take the average of it.
Thank you. God's sakes, how long does it take me to pull teeth here? You would figure the average, right? So you have three results here: 18.72, 52.73, and 32.74. How do you figure out what you think your result would be?
You add them all up and divide it by 3.
Thank you so much. I do that math out and I come up with an answer of 34.73%. Now, 34.73% is compared to the real number. Is that very close?
The results are neither accurate nor precise.
Thank you. Okay. I'm not even going to go into this one. I'm not going to go into this one with detail because I've already told you how to get the mass of the hydrate. This next question, I've already told you how to get the mass of the anhydrous. And I've already told you how to get the mass of the water. And this is probably going to be the mass percent. Okay. So these last 4 questions I've already gone over. Questions? Any more questions, ladies and gentlemen?
No.
If it wouldn't have taken you 20 minutes to figure out average, you'd have been home 20 minutes ago.
We are home.
Leave me alone.
Okay, seriously, that's all I got for you. Okay? So, unless you want to hear me talk boring things to Brittany
And Mac.
and Mac. Okay, Mac, you want to know about the density as well, right?
Yes, sir.
Okay. Unless you want to hear about that, ladies and gentlemen, I'm done with you.
Thank you.
Take care. Was the sandwich good, Kara? She left. I'm sitting here, I'm starving, and she's eating a sandwich right in front of me. Okay. Are you guys just sticking around to see if you can get any tidbits from Brittany and Mac?
Yep.
Okay. Fine as kind. All right. Now, no, I don't want that. I want this. Okay. All right. First of all, I'm going to show you, Brittany, where the data is. Okay.
Okay, I'm just screen recording.
Why are you screen recording?
This is recorded.
The meeting's recorded.
And where can you find that?
YouTube.
Amazingly, you can find it in YouTube. You can probably find it quicker in YouTube than in the course, but I'll show you where it's at in the course.
I just subscribed to him, so it just pops up.
Ah, okay.
I have no idea what you guys are doing, but okay.
I have a very forgetful mind, so.
Well, this is easy. All right, we're in the course, got a course content. Go all the way down to the bottom, almost to the bottom, and you will see Zoom meetings.
Okay.
Click on it. Go all the way back up to the top. Download it. Then simply, all you have to do is control, click.
Just click it. Just click it.
Click it. Yeah, it's highlighted.
Okay. And
Awesome.
you know more than I do. Literally speaking, this recording will probably be uploaded sometime tomorrow.
Wish I would have known because I missed last week's class. I would have watched that.
Well, you can watch it now.
I sure will.
All right, now, what you're going to do for the experimental data, you're going to go down to here where it says student data for labs. Okay?
Oh, okay. Because I was using, I think, as the lab manual. Yeah, it has to be. And I was just like, there's not enough information here.
So you
Student-
go there,
Yeah.
download that. And
I'm
amazingly,
I'm getting used to this. This is my first time taking a lab online, so
looky here. Density, dry lab data. Okay, Brittany?
Okay, and for the lab notes or notebook,
Okay.
I have that whole piece printed out that you have in your syllabus, and I think I'm still having troubles understanding it. Like I see the parts that you can cut out. I'm not exactly 100% sure what you are looking for in that book, and I wanted to
hold
come
on
next.
a second. Hold on
Okay.
a second. I got to figure out where I got to be.
didn't you say we can just recreate the boxes and stuff by hand in our notebooks?
You can do it by hand. The data tables, you can do it by hand if you want.
Yeah, that's what I did from the lab manual.
Trouble is, I got to figure out where it is.
The lab manual?
No,
Right there.
the notebook. Where?
Right
Oh,
there. Go up, Professor.
I
Is under
think
your
it's in
syllabus.
like,
Is in
yeah,
your
I
Safety?
syllabus.
Is it in the safety?
Yeah, no, not safety, just the syllabus. Go up. Right there. No, no, go up. Keep going up.
I don't think it's in the
I
syllabus.
think it's in the begin here.
Click on the syllabus.
No, I don't think it's in begin here.
No, no, no.
Mm.
On the syllabus on the top, all the way at the top.
Right. Lab
Okay.
notebook requirements right there.
All right, this is Dr. Musgraves.
Yeah, I've watched it and
This is Dr. Musgraves.
okay.
Yours is in the syllabus, Professor.
I have the syllabus
it's
part
not.
printed
Go all
out.
the way down. Right there.
No,
Oh,
no.
Nope.
That's still Dr. Musgraves.
Oh, that's what I used.
Okay, well, that might explain some things, Mac.
Is the course is very poorly made, Professor.
Oh,
The
Well-
pre-lab, I missed the pre-lab for the thing because I thought I got everything in the folder done, but the pre-lab is in the
next folder.
next folder, so it's very stupid.
what?
The pre-lab instead of being on the in the folder
Okay,
for
we'll go. This is density. This is the density folder.
yeah, but the pre-lab for the percent composition of the hydrate salt is not in here. Is in the next folder.
So you missed it.
Right
So I
there.
missed it.
He
Mac,
thought he
it's
was
right there. Mac, it's right
Yeah,
there.
but I thought I finished everything. I thought I got all the assignments done. Then
Mac, I give you every Sunday. I've been giving you what's due.
I know, but I didn't see it in the folder, so I thought maybe
No, if I tell you it's there, it is there.
no. I'm
Okay.
getting the hang of it now. So
All right.
is there any way you can open it till
No.
tonight?
No, the whole purpose before my making you do pre-labs is so that you read the
I did read-
manual.
I did.
It doesn't make any purpose for me to let you do it now.
Well, this is the second one I missed. So
You get to miss too.
oh, I do get to miss too.
Yes. Don't miss
Oh.
any more.
I will not. I'm getting a hang of
Swear
it.
to God.
That's it, Professor. That's all we got.
No, it's instructor notes. Look at instructor note. I knew it was in there somewhere. Okay. There you
Okay.
go. Go all the way down to instructor notes.
okay.
Dr. Musgrave has so much shit in this thing that you can't find anything. And God
Same with
forbid, have you looked at the grade book?
No,
Mm.
I don't want to.
I have.
Isn't it a total mess?
If it's the one I'm thinking of, it made me think even though I did all my assignments, I still have an F.
Well, that has to do with the fact that all the assignments are given zeros.
Yeah.
And what he did, okay, now that I know where this is, let me show you what the notebook is. Okay. He was getting so many questions from students about what is your grade? What do I need to get an A? So what he did was he created this monstrosity. And so I'm sorry, I got to move this silly thing again.
I get it. It just says F. I understand.
Yeah, we see it on our side.
So all right. Where is that thing? Oh, there it is. Okay. You have all these things have to be in there because these are all your grades. Okay. This
Mhm.
stuff makes sense.
You're
Okay.
talking about the SSI bonus thing at the
No,
end?
you're not going to get an SSI bonus. I don't give bonuses. Okay. Okay. These are all the grades that have to be in there. Then we're going to go to the post labs. Okay. Those all have to be in there. Now, practical final. Now we get to lab notebooks. Now, you get to this part, Points needed to get an A, points needed to get a B. Letter grade after this, letter grade after that, letter grade after this. Okay?
Mhm.
All these things are because he doesn't want to explain individual grades. Anyway,
Okay.
sorry, that was my rant.
Mm.
Let's go back to where you wanted me to be. Okay. Lab notebook. It's a PowerPoint.
Just to, okay, yeah, I was gonna ask that. Just to make sure that the lab notebook, the PowerPoint was yours, not the other professor.
Okay. Ah, crap. I don't like doing it this way. I have to do it. I know what I'm doing wrong.
So I'm not the only one who's having trouble with the lab notebook. I feel less stupid now.
Okay, I would download the
I just printed out.
okay. Okay, now Brittany, it goes through and I tell you what is expected. Okay, what the objective is, how to get the chemical hazards. I give you an example of what one looks like. I want you to give me immediate hazards, and I want you to give me long-term effects. Then the next thing, you have to rewrite the procedure. Okay, rewrite the procedure, give a step-by-step explanation of how you're going to do the experiment, and you want to be detailed enough that somebody can follow you, and without going to the lab manual, they can replicate your experiment.
Are you showing it to us right now, or
You're not seeing it?
no? We're not seeing it. Or I'm not seeing
Okay.
it.
Sorry, are you seeing it now?
Yes.
Yes.
Thank you.
What happens when you download something, when you're in a screen sharing, it doesn't allow you to show what you've downloaded. So those are the sections I want. Gives a simple explanation of what an objective is. Chemical hazards, I want long-term and immediate hazards. If you Google a safety data sheet, you'll get something like this. So you have to read through this and you have to quickly come up with a quick summation on what the immediate hazards are and what the long-term hazards are. Okay?
Mhm.
Then the next step, you're going to do the procedure. That is a step-by-step explanation of how you're going to do the experiment. And what I did was I gave the example of rewriting the empirical formula procedure. And that one happens to be rather long. Okay? Data table. Okay? You have two choices for the data table. You can use what's in your lab manual. Your lab manual does have data tables. And you can write on that data table. But it has to be put into the notebook in some form. If it's in there as a loose leaf form, it doesn't count. You have to staple it, glue it, tape it, somehow affix that data table into your notebook. Don't include calculations on it. You have to give me one calculation, birth to death, separate section. By that, I mean, if you didn't measure it, somehow that number was calculated. If it was calculated, it needs to be in the calculation section. This happens to be the empirical formula again. All the equations that are needed there. Okay, Then we get to the last section, the conclusion. Your first statement in the conclusion should answer what the question that was raised by the objective. Today's objective: find the mass percent of a hydrate. That's all you're doing. All right. Your first answer to that is the mass percent of my hydrate was this percentage. It matched the mass percent for a formula with the for the formula such and such. Okay. Then you need to figure out error analysis. Do you have an error analysis for this experiment? Do you know what your answer should be? Because you know what the formula is. From the formula, that will give you the mass percent. Your answer should differ from the formula answer. So you should be able to do an percent error analysis here. I want you to posit an error that could have happened. What would happen if you didn't heat your sample enough? Brittany, how would that affect your results?
You could get a wrong reading.
I'm sorry, I
I-
had my mute on. Is it because like your not enough heat won't take enough water out?
If it doesn't take enough water out, how's that going to affect your percentage?
Your mass. will be
Mass.
different.
Ultimately, you're figuring out the percentage. If you did not drive enough water off, how is this affecting your percentage?
It's going to be a higher percentage.
You didn't drive off enough water. So your water weight is lower than it should be.
So you, lower percentage.
It's going to be a lower percentage because your water weight is smaller. If your water weight is smaller, dividing that smaller number by a bigger number is going to give you an even smaller percentage than you should have. That's what I'm talking about, analyzing your results. And there's a couple of formulas I have back here.
Do you actually have a notebook version of what you're
Example.
looking for?
Yes,
Like a
I do.
picture of it.
Yes, I do. The last couple of things I mentioned, there are a couple of error analysis numerically. One is percent error. This tells you how accurate your results are. And the second one is standard deviation. This tells you how precise your answers are. Error
I just
analysis,
think-
percent error, I've already just gone over. Standard deviation. The way you get standard deviation is you take the absolute value of your trial one value minus the average. In other words, this number is going to be positive no matter what you do because you're doing the absolute value of it. Then you're going to add to that trial 2 minus the average absolute value plus trial 3 minus the average absolute value. You're going to add up all the trials minus the averages, and you're going to divide that by the number of trials that you did. And I have another example down there below. Okay.
At this point, I'm just confused. I thought I was getting it, but now I'm just more confused.
Read through this, Brittany.
I mean, to me, it's just gibberish. All this just looks like gibberish. I mean, I started understanding the first half, but now I would just need a physical copy to look at because this just isn't.
All right, relax. I don't need this. That's what the problem was. Okay. Okay. Can you go back to lab instructor notes? exemplar notebook. And what I did here, the first page is out of order. Okay? It's out of order. This is your first page. Okay?
Okay.
Objective, chemical hazards. Now the second page, end of the chemical hazards. I go in and talk about procedures. Okay, that's the end of the second page. Procedures continue on to the third, or that was actually the end of the procedures. Then, actually, this is the notebook for this particular lab. This is the entire data table I have. I do the calculations. I get the mass of the hydrate, mass of the anhydrous, mass of the water divided by the mass of the hydrate. Then I compare it to magnesium sulfate. I find out what the percentage of mag sulfate of water and magnesium sulfate is. I've compared that to my mass percent. They're pretty close. So that's what I'm calling it. Okay?
Mm-hmm.
Under the results, first sentence, the mass percent of my sample was 50.11%, which compares favorably with the formula mag sulfate.7 H2O, which has a percentage of 51.17. Done. Done with that first sentence of the conclusion. Then we go into error analysis. I'm saying because we live in a humid climate, it's possible that the anhydrous sample could have absorbed water. In the time it took for you to take that anhydrous sample from where it was to the balance, it gained water. If it gained water, if the anhydrous gained water, that means when I did that subtraction, I would have had less water, which means that my sample should have had a lower percentage than the real sample, which is how I'm explaining why my sample is lower than it should have been. Okay?
Okay.
Brittany, does that explain things a little better?
Yes, having a physical copy.
Hey,
Give me
I
something.
aim to please, Brittany.
Well, I just honestly, I didn't know that thing was all the way down there. I thought we were going off of the video or what was in the syllabus.
And bottom line, you're going to screw up for the first couple of lab reports, unless you're totally anal. And there are some people that have gotten them right so far, but you're going to screw up. What I do for you is I let you keep on trying. When you finally get it right, all of your previous lab reports that you have submitted, all the previous ones that you have submitted will all get a perfect score at that point.
Okay.
All right?
Mm-hmm.
And then it's up to you to keep it up.
Yeah. Okay. Definitely helpful.
Okay, Mac. Now let's get to you. What did you have?
Well, I talked to you earlier. You told me to talk to the help desk. They told me that I have to use Imager to copy and paste the picture for the result to get the
Okay.
picture.
So we have a solution.
Go ahead.
At least we have a possible solution, right?
Yes.
There we go.
So now,
go ahead.
Now, how do I get it to you? The course post.
Okay, if you have gotten the picture, I told you.
Put them all in the next one?
Put it in the notebook, right?
Yeah.
You're going to have to submit pictures of the notebook as well, right, Mac?
Yes. I have to
Just
submit pictures of the notebook and then pictures of the graph for
Just
the
Just
result.
include all those pictures in the Dropbox submission for the notebook.
Okay.
All right.
So I'll post it with the notebook post with the percent composition of hydrated salt. So I'll post all 3 of them for you.
Okay. Is the notebook for the density done?
Yes, sir.
Okay.
The notebook for density and the other one. They were both done. I just didn't know how to. For density and chemical and physical
What
changes.
I'm
are both
asking,
done.
what I'm asking is, can you submit them yet? Are you able to submit them? Mac, I will make sure that you're able to submit them. Okay.
I will. I haven't tried it, but I will try and email you.
I will, right as I'm getting off here, I will make sure that you're able to submit them. Okay.
Thank you so much.
No problem. Brian, do you have any questions?
No, no, sir. Have a good night.
No, I'm not kicking off. I'm just, if you have nothing more, this is about I'm trying to end things up.
No, yeah, I'm good.
And
I
who
was
the
just
hell
sticking
is,
around.
who is Santiago?
I'm not sure. Have a good night.
Who is Santiago? Okay. Going once, twice.
Have a good night, Professor.
Have a good night. Mac, Santiago?